Okay, so let's go ahead and talk about what's your type. So in this PowerPoint, we're going to be introducing just the five basic chemical reactions that we're going to see. The quote that we have here, there are two kinds of people, those who do the work and those who take the credit. Try to be in the first group. There's less competition. So we're going to look at the types of reactions, and what we're trying to learn, our learning goals for this is: number one, students will understand the major types of chemical reactions by determining the types of unknown chemical reactions. Basically, what we're saying here is that we want to be able to look at any chemical reaction, and you should be able to tell me what type of reaction it is. We are also going to Students will understand the role of oxidation reduction reactions and precipitate reactions. So very specific types of reactions that we're going to see: the oxidation reduction, precipitate, those types of reactions. We need to know what those are and just some definitions of those. So, how many different types of chemical reactions are there? Well, there's a minimum estimate of a possible chemical compounds of that is 10 to the 18th, so 1.0 times 10 to the 18th, a very large number. And so basically, since there's that many types of chemical compounds, this makes the number of possible reactions practically infinite. It's a very huge amount. We're going to talk about five major types of reactions. We have synthesis, decomposition, single replacement, double replacement, and then combustion. And the reason why we have types of reactions is because we like to categorize everything as best as possible to try to make the data, try to make everything just a little bit more manageable, because the types that we have, the number of possible reactions are practically infinite. So we try to box them in and put them in five types of reactions. So, how do you tell what type of chemical reaction you're working with? It's all about the reactants in the products. Okay. Now we've learned so far. Remember, the reactants are going to be what you start with. The product is what you finish with. So we're going to look at how do the reactants change, and do they combine, separate, or switch partners? So these are the questions we're going to be asking ourselves to really figure out what type of reaction we have. Remember, we're focusing mainly on reactants and products. Okay, what we start with, what we finish with, and basically we're looking at how they change. So, how do I know that if a synthesis reaction has occurred? Okay, if both of the reactants from one single compound they form the product, you have a synthesis reaction. Okay, so if what you start with, they form one single compound for the product, okay, then you have a synthesis reaction. Okay, so basically what we have, if you go from two or more things to one thing, you have a synthesis reaction. Other ways that we say synthesis, they also call this a combination reaction. They're combining. An example of this, we have our magnesium plus oxygen produces magnesium oxide. So magnesium is all by itself, and we see it right here. Okay, it's a picture of magnesium, and then we have oxygen from the air. They combine to make this white powder, which is magnesium oxide. Okay, so two things becoming one thing is a synthesis reaction. So how do I know if a decomposition reaction has occurred? If a single reactant breaks up into different pieces for the product, you have a decomposition reaction. Okay, basically this is the reverse of a synthesis. So this is one thing becoming two things. Okay, so in this case we take water, okay, and we break it up into, here's a picture of hydrogen and a picture of a container of oxygen. And so water is H2O, it's made of hydrogen and oxygen, and so we break it up through electrolysis. We run an electrical current through it, break it up, and we get our hydrogen and our oxygen. So decomposition, it decomposes, it breaks into its pieces. It goes from one thing to two things. Okay, how do I know if a single replacement reaction has occurred? if a single element switches places, so here we see that it's switching places with a like element in the compound to produce a new product, you have a single replacement reaction. I would make a note here that like replaces like. Okay, so if the element that's by itself, like in this case, iron, it's all by itself, it's a metal. So it's going to replace the metal in our compound, which we have copper 2 sulfate, which is right here. So sulfate is going to be an ion. Copper, that's a metal. So the iron switches places with the copper, and we see that copper comes out here, and then iron is now bonded to that sulfate. They switch partners. Okay, way we can remember this, if we have an element plus a compound produces an element plus a compound. That means that we have a single replacement reaction. Okay, how do I know if a double replacement reaction has occurred? Okay, if both of the compounds switch partners in the product, with the element that they are bonded to in the reactant, you have a double replacement reaction. Main way we can see this, a compound plus a compound produces a brand new compound plus another compound. Okay, so we see here we have lead nitrate and potassium iodide. So we see them both right here. So the metals will switch partners. They switch. So potassium was bonded to iodine. Now it's going to be bonded to nitrate. So we have potassium nitrate. Lead was bonded to nitrate. Now it's going to be bonded to iodide. So we see we have lead to iodide. They switch partners. Our last type of reaction that we see is how do I know that a combustion reaction has occurred? So if oxygen reacts with a compound to produce heat and a product of at least water. So we say this, that oxygen is reacting with a type of compound, any type of compound, and it will produce water. In most cases, we see that it's the combustion of a hydrocarbon. We can see here's our example. We have methane. Okay, methane is a hydrocarbon. It's hydrogen bonded to a carbon. We see we have methane. Then the oxygen is reacting with the methane, and it produces, in this case, there's the water. And if it's a hydrocarbon, so if it's some type of CH something, you're going to have carbon dioxide as a product as well. Okay. In most cases, all it has to have is just oxygen reacting with something to produce water. You can think of the combustion of hydrogen. So hydrogen gas plus oxygen gas will combust to make H2O. Okay. Oxygen reacted with hydrogen, it produced the water. That's all you need. But normally with a hydrocarbon, you're gonna see that CO2. Okay. So let's look at an example. It says describe what types of reactions are involved in the isolation of copper. So we have copper 2 nitrate is combined with sodium hydroxide, and we see that it produces copper hydroxide and sodium nitrate. So let's look at what we have. Copper 2 nitrate, that's a compound. Sodium hydroxide, that's a compound. It produces copper hydroxide. So what happened here is copper and sodium switch partners and produce copper hydroxide, which is a compound, and sodium nitrate, which is a compound. So in that first reaction, we have a double replacement reaction. Okay, that's the first one. Okay, and it says the copper 2 hydroxide is heated. So copper 2 hydroxide, let's use a different color for the next reaction. So our copper 2 hydroxide is heated to produce, so there's our arrow, copper 2 oxide and water. Okay, so we look at it. We have a compound that breaks up into two different compounds. So we went from one thing to two things. So when we go from one thing to two things, that is going to be, the second one is going to be a decomposition reaction. We went from one thing to two things. Okay. Then the copper 2 oxide is then added to sulfuric acid and produces, here's our next reaction, copper 2 sulfate, and water. So again, we see that that's a compound and a compound. It produces a compound and a compound. So we see that the third reaction, is going to be a double replacement reaction. It says then zinc is added to the copper 2 sulfate and zinc sulfate. Okay. It says then zinc is added to the copper 2 sulfate. So zinc is added to copper 2 sulfate, and it should and produces zinc sulfate and copper metal. So it should be produces right here. When we see this, zinc, which is an element, plus copper 2 sulfate, which is a compound, produces a compound and a different element. So our fourth reaction will be a single replacement reaction. Next example, it says label the following reactants as synthesis, decomposition, single, double replacement, or combustion. So the first one, we see we have an element plus a compound produces, that element's now by itself, and a compound. That is single replacement. Okay. Then we have a hydrocarbon plus oxygen produces CO2 and H2O. So oxygen is reacting with that. We see that water is produced, and we see that carbon dioxide. We already know that it's a combustion reaction. Okay. The next one, we have our copper chlorate, or not copper, but potassium chlorate, and it breaks up. It goes from one thing to now we have two things. So if we go from one thing to two things, that's a decomposition reaction. Here we have an element, and an element produces a compound. So two things become one thing. That's a synthesis reaction. And then lastly, we have a compound in hydrochloric acid. We have a compound in sodium hydroxide, produces sodium chloride and water. So we see that now sodium, and we might not be able to see this. Anytime you see water, especially in chemical reactions, you can think of it as H bonded to OH. So hydrogen bonded hydroxide. You can think of it that way because we see that the sodium is now bonded to chlorine, and that hydrogen is now bonded to that OH, which produces H2O. Okay, that's a trick that you always got to look out for. That hydrogen went with that hydroxide, and which produces H2O. So this would be a double replacement reaction.